All right, well, I think we'll go ahead and get started then. Thanks for joining us. I'm sure people will be filtering in as we continue down this road. There's Mark Duggan. Hey, good morning. So a heat pump water heater. Obviously, these heat pumps are here to stay. Dominantly right now, we're seeing them in a lot of domestic water production. Soon we'll be exploring a little bit deeper dive into hydronic. But with that in mind, as we get started, this is all about sustainability, where we're introducing a portfolio of products that are sustainable, that have multiple benefits to the bid spec market, engineers specifying. So we really want to cater to that, give this some added focus. And we've already met a lot of our training goals. Up to 2025, we had intended to train 250,000 contractors, and we surpassed that goal even as of last year. So a lot to be said about sustainability in this product. Moving forward, going to do a little bit about pre-startup. Obviously, we're going to do startup and commissioning, but before you even get there, it's important to do a site review, and there's multiple reasons for this. We're going to cover that startup checklist. We're going to talk about programming, as well as the formal startup and commissioning. So this will be available as a recorded webinar. It will be posted to our raypaktraining.com site as a recorded webinar. If you are interested, I can send you a PDF copy of this presentation as well. I'll display my email at the very end. Okay, so with that, we'll just keep jumping right in. This is actually a fairly straightforward, somewhat small presentation, short in length, I mean to say. And we're going to go through all this in terms of a site review, showing up. Is the wiring correct, which is a big aspect of it? Our local area network wire, our land wiring, that basically, and if it were a boiler or a water heater, we would say it's cascaded. But in the heat pump world, they use the terminology of a LAN. Sensors, we're going to look at proper landing of the sensors, the proper wiring of the circulators. Is it piped per RIOM? Tanks, the relief valve, or the tanks piped per the relief valve. So all these things prior to a startup and commissioning, this is important. In fact, I tell this story frequently. A couple of months ago, our rep in Kansas City, I was going to walk them through a X-Fire startup and commissioning, and they got there, and the breaker, the panel, was locked out, tagged out, and water pressure was 125 psi, which is a code violation on domestic. Anything over 80 psi on a domestic system is a code violation. So they were unable to even do a startup and commissioning on site just because of the conditions that were present at that particular time. So I really highly recommend a pre-checklist being signed off on. A lot of you as rep agencies have your own pre-checklist that has to be signed off on, and we're big advocates of that. Here is the display of the checklist. In every installation and operation manual, you will see our startup checklist, and we'll go through some of these today. This is the form that would need to be filled out and then sent to our, well, there's a different site down here, registermyunit.com, raypak.registermyunit.com. So again, we'll go through all this again today. We do want to talk briefly about the optional units. This is not a cloaked sales meeting, but a lot of times we'll get end users that are saying, what are my available options? Why isn't it on a job site? So circulators, if you're doing BACnet or any type of BMS and storage, those are also going to be options. The one also very specific option is if you're ducting the cool air away from the unit. We do not offer a ducting kit that takes warm air to the unit, but we do offer a ducting kit that will remove the cool air away from the unit. So on our startup and commissioning, if we go through this as a punch list, things that we're going to be looking for, there's the close-up view of the panel, if you will, where we're bringing our primary power in. So the smaller units are 208 or 240 volt single phase, as displayed here. And then we'll go right to the circulator for that same unit. That terminal block is right there. These are essentially dry contacts so that we're switching power through these contactors. Again, we can switch whatever power we want through there. On the larger units, that is 480 volt three phase, so that wiring will necessarily look a little bit different. Making some notes here. Again, I'll just want to remind everybody, you are all unmuted on this end. So if you have a question, just go ahead and unmute yourself. We can revisit any slide. All my slides are numbered on the lower left-hand side. So again, we want to be very open and welcoming to any questions you may have moving forward here. The circulator for the larger unit, again, we can do 480 volt three phase, or we can use this contactor. We can switch power to whatever circulator that you choose. I know as rep agencies, there's a lot of really good circulator manufacturers out there that you might be representing, and you're welcome to utilize this. The wiring, again, I would hazard a guess to say most of our projects for domestic water production as well as space heating are going to be multiple units. So again, we used the words earlier of local area network wiring, or what in the boiler world or water heater world we would consider to be cascade. So again, as a common thread, it's very common to get to a job site and the low voltage wiring is not done. I mean, it happens all the time. So again, we like that sign-off checklist. Who's got the ball on this? Who's doing the wiring? And so this is essentially point-to-point wiring. We do offer a cable that simply plugs and connects from each unit, but then also each unit will have a jumper across it, as it's shown here. The leader on this particular terminal, as located below the display, there is a terminal block, and that terminal block for the first follower will have a jumper that looks like this. The second follower will look like this, and so on. And again, we can cascade up to 4 units. And again, multiple banks of 4 heat pumps is absolutely acceptable. So what this really does is, you know, the leader is going to engage based on a set point demand, and then everything in sequence connected to it as a follower will follow suit. So these jumper wires essentially set the personality of the follower so that this jumper that you see right here will recognize that, hey, I'm the first one attached to the leader. I'm the second one attached to the leader. I'm the third one attached to the leader, as it were. Right, so very, very straightforward, you know, as it pertains to wiring. And there is a programming that will follow suit here that we'll talk about as well. The landing of the tank sensor, very straightforward. What I'm illustrating here on this terminal strip is 1 wire plus a ground. And again, the ground is not illustrated. So it'll be a 2-wire thermistor sensor, and I'm illustrating where these wires go minus the ground. Very easy, very straightforward to follow. As it pertains to programming, this is a very straightforward control. We'll look at each of these buttons here, the escape, the program, the alarm, but the up, enter, and down button here on the right, those are going to be your primary points of interface. There's going to be some moderate programming involved, but again, we're going to go through some of those. Let's just say the top 10 programmable things that you'll have to interface with on a job site. Very, very straightforward. So on the display itself, there's a lot of usable information. You'll note that right here, as we get this unit, sometimes they come to us where they are defaulted in Celsius, and we'll talk about programming, how to get it to change it back to Fahrenheit. It'll also give you pressure readings in kilopascals, and we can get that back to PSI, and we'll talk about changing those units of measure. But there is a visual indicator that the unit is on. You'll see the entering water temperature, you'll see the exiting water temperatures, 24-hour time clock if you've taken the time to set that up in the display. There is a feature that you'll see if the unit, even though it's on, when the compressor is cycling, you will see that check marked. Program that day and date feature. Outdoor ambient, if you've supplied that outdoor air sensor, or if these units are installed outside, it will be at the outlet sensor. You will see that temperature information. And then, of course, the storage tank information, the sensor information, and then, of course, the exiting temperature. And we know that if we pipe this and plumb this correctly, we should see a very narrow temperature rise across that unit. Again, this is a multi-pass system. We're circulating cool water in via that compressor. We're extracting heat and sending it right to the tank in multiple passes. So anywhere between a 5 and 8 degree rise across this unit will be able to be displayed here. And again, we'll change this back to Fahrenheit. So we can see that we have maybe 130 degree water going in, 138 degree water going out into that storage tank, trying to satisfy set point. I'm going to go ahead and pause, see if we have any questions. Again, if you do, just unmute yourself, ask away. Okay. Again, just a quick narrative on how to navigate. I'm going to go to the question block, make sure I don't have any questions here. No, doesn't appear to be. So again, these buttons on the right, along with the escape button, again, is going to give us a lot of information in terms of navigation. So press and release the up arrow or down arrow so that you can navigate to a particular menu. This middle one, it looks a little bit like a left-hand arrow, but there's a little bit of an uptick here. But that's what our enter button essentially looks like. So we'll navigate to that main menu. Then from that main menu, we can again navigate up and down for individual parameters. Again, hit the enter button to a desired parameter, change that parameter by hitting the up or down arrow, change a temperature, plus or minus. Again, we're going to hit the enter to accept that parameter and then escape to navigate back one screen so that we can continue on. There's a lot of a large menu of items to program, but we're not going to need to navigate to each and every one of those. We're only going to navigate to maybe 5, 6, 8 on a particular job application. And again, if you hit the escape button, that will take you back. Multiple presses of that escape button will take you back to that home screen. Very easy to navigate this. Here is a simplified menu. It's not holistic. It's not going to give you every adjustable parameter, but it is a base menu where it has 8 submenus. So you'll see A, B, C, and again, very easy to navigate to these base menus. And from there, navigate up and down to these individual parameters. And again, not all of the parameters are displayed here because it's a fairly lengthy menu, but this is going to give you a lot of good usable information. I did take the time, I got my geek on and I took all this information and put it in a spreadsheet, and I'd be more than happy to send a spreadsheet to you. What I did also was color code it so that in dark blue with white lettering, I did basically a top 10, top 15 that I thought would be helpful. So here's how you navigate to that A menu, the master menu. You program down to these individual parameters with that up and down. Some of these are password protected. Some of these are not password protected. So you'll have to enter this code based on the parameter you want to access, and that will then allow you to make those necessary changes. I completely understand this is a lot of information, but again, you're not going to need to navigate to each and every one of these parameters. Very few, in fact, will you need to navigate to. In fact, here's in a lighter blue, there's only 3 programmable features if you're navigating to adjust a BMS. If you're going to add a BMS communication, there's very few programmable features that you'll have to navigate to. And again, I can send this to you on request as this spreadsheet as we move forward. So again, a lot of information here. I don't think you're going to need to navigate to all of it. So that's why I put together this top 10. And we are going to go through and just walk through the programmability of these, because if you break it down like this, very, very simple. Here's my base menu A, navigate to the on-off menu. Basically, the default is off. I hit the up arrow, turn it on. And in this instance, in this menu, it is not password protected. Okay, on-off for pump, even though you would think that the default would be if I'm landing the wires to my pump, I still got to go into the programmable feature and say, hey, I do have a pump attached that my pump contactor is controlling. Let's go ahead and enable it. Clock and date, I think it's valuable to set up the date and time so that you can start to track fault codes. If something happens, you can correlate that back to a particular date timestamp, if you will. These are important. Again, none of those are password protected. They're fairly forward facing, I would say. Set point. Here is a set point. Very easy to access. This one is password protected. So we'll put in this password of 0022 and hit enter. And then we can go back and hit the up and down arrow. And if we're storing water in our tank at 140 degrees, we're going to adjust that set point up to 140 degrees, and off we go. The differential in a domestic water production mode, the default is 5.4 degrees. Don't ask me why. Well, I can tell you why, but let's not bog ourselves down in that minutia. But let's say I want to adjust to a 10-degree differential. So if I have 140 degree stored water temperature, when that tank falls to 130 degrees, that's going to actuate the call for heat to the individual heat pumps. So again, this is completely adjustable as well. This one is important, unit of temperature, unit of measure. The default is Celsius. Sometimes we get them into our factory that it's already been programmed to Fahrenheit. But again, very easy to navigate to this menu, the G menu, toggle over to service. The up and down arrows will navigate you to that individual parameter of temperature, unit of measure. You hit enter. We can select the up and down arrow to select Fahrenheit, hit the enter, and it'll again ask us for this password, and off we go. So very, very easy. I would say that these top 8 right here are going to be on every job, whether it's a single unit or multiple unit. If we have multiple units, the other programmable features that we're going to need to discuss is number of compressors. Maybe I have 4 units in an application, 4 heat pumps rather, or maybe I only have 2. It's going to want to know how many compressors are tied in. So this is a programmable feature that not only are we tying in our low voltage wiring, we have to go in and program the unit for how many compressors are attached in this cumulative sequence. Compressor staging. This is interesting. We're going to talk about that and show you more what that means, but the default is simultaneous, and we can program over to a staggered method. So we'll talk about this here more fully here. So again, just navigating, knowing what your system looks like is the biggest thing. What is my number of units? Do I have 2 tanks that are properly reverse returned? Do I have 4 tanks properly reverse returned? All these individual things again. Navigating to my on-off menu, we go to the ID of A that you saw earlier. We program down to the master menu, the on-off menu, navigate to the parameter on-off, and then that up and down arrow, we select on. So again, very easy to navigate to. I know it's difficult because we're doing this virtually, but if you come to the factory for training, we do now have simulators. If you've been to our Oxnard ILC, we bring out our simulators for that Versa IC training that allows you to put your hands on and learn to program. We also now have 10 brand new simulators for the heat pump so we can practice programming together. I think it's a very nice feature. So we again welcome you to attend our ILC training in Oxnard as well. Here's that programmable menu for the circulator. Again, going to that first menu, navigate down to our second menu, then to our parameter, and then hit the up arrow, select the on button, and we've essentially allowed that unit to turn the circulator on when the call for heat presents itself. Date and clock, here's where we're navigating to. Here's that C menu that I talked about. So in the upper right graphic right here, we're navigating to the up and down arrow to the C clock scheduler. We hit enter, specifically the clock. We again then can set the date and time for that clock function. Input and output, this is again going to be specific to a multiple unit configuration. I'll give you a glimpse into this moving forward here. Here is set point. I'm actually working on it. Anytime you see a placeholder, I'm actually going to get this changed to Fahrenheit and display what it is actually looking like in our hot lab. So again, we're always making these small running changes where I'm going to be able to show you, but here I'm going to illustrate the next time I'm at the factory on these simulators that we can program it in Fahrenheit and not in Celsius. Again, with the differential, we're navigating to that G menu, the drop down to the service menu, the adjustable parameter of differential, you hit enter, and then the setting will populate itself, and then we hit that up and down arrow. We can make that whatever we want. Then we hit the enter button again to accept it, and then hit the escape. Very easy to program these units. Here's unit of measure. We can also do unit of measure for pressure as well. There we go. Let that update here. Here we go. And here's where I was talking about number of compressors. So we go to the G menu, navigate down to service. The individual parameter we navigate to is number of compressors. And here's where we're going to adjust the number of compressors. So again, very straightforward, very simple. We'll be there to walk you through it. Tech assistants will be there to walk you through it. Very easy to do. Also on this screen, I'm backing up here again. Here's where that default was simultaneous. And this again is the type of cascade that we're talking about. Well, what does that mean? Well, here's what that means. The default is simultaneous, and the default differential, as we said, was 5.4 degrees. Here I'm just illustrating a scenario where I have 4 heat pumps in a sequence. So in the simultaneous mode for domestic water production, if I drop 5.4 degrees from my stored water temperature, the leader is going to suggest, boom, great. We have a demand. Let's call for heat. The unit is going to turn on. Well, there is a default adjustable parameter, but the default is 20 seconds. So in the simultaneous mode, after 20 seconds, the next unit will turn on. And then after 20 seconds, the next unit will turn on, and so on. So it's basically a bang, bang control. So all 4 heat pumps are going to stage on within a minute so that we can try and satisfy set point. As we approach, or rather, as we achieve set point, boom, all units will turn off simultaneously. So that is the default simultaneous method. Again, we showed you in the previous screen. Here is where you go again, simultaneous. If I navigate down to that menu and I hit the enter button, I can hit the up arrow and I can select staggered. That is a programmable feature we can utilize. Staggered is a little bit different than simultaneous. Staggered breaks up the differential. Let's say again, we keep that same 5.4 degree differential. It's going to break up that differential into even parameters or even values, if you will. So in essence, if I had a 10 degree differential, it would break it up into 2.5 degrees. So when the first unit, when my stored water temperature is maybe storing at 140, when I drop to 137.5, the first unit would come on if it was 2.5 degree differential. So again, it breaks it up evenly, and then of course it will also go into that 20-second delay. But here, instead of a bang bang approach, if you will, here I have more of a soft start, soft stop approach to those individual heat pumps. Now, I know as we saturate the market and we have more projects going on, you'll get more intuitive on this, but with our boiler products and water heating products with the Versa, we have the ability to rotate leaders. That is not the case with this heat pump in its present offering. The leader is always going to be the leader. The followers are always going to be the first follower, second follower, third follower, and so on. So we don't have that little bit of added elegance. The leader is always going to be the leader, always going to be the first to stage on as we program these units. So again, we can go back to that navigating that menu for compressor staging, the number of compressors, as well as we can navigate to the simultaneous. We can hit the enter button and hit the up so that we can toggle on staggered instead of simultaneous. I think for domestic water production, I would leave it in the simultaneous. Perhaps for space heating in multiple units, maybe there's a little bit more elegance or a conversation that we can have about using the staggered approach. I think you'll develop it over time, but I think for domestic water production, simultaneous is sufficient because we want to satisfy that load as quickly as possible. With space heating, I think we're not turning on a dime trying to satisfy set point. We can stagger those on based on differential. BMS, again, we talked about that as available option as well as programmable. Here's where we're going to navigate to that menu if you order. And we do cover this in our waves presentation, basically our installation presentation. This is an an optional feature. It's a little printed circuit board and terminal strip that plugs into this module right here. And from there, you have the expanded ability to program some BMS features of address, protocol, and your baud rate, your speed. Very easy to navigate to. That was a little bit of a whirlwind tour of programming. Again, I think over time, we'll have some added functionality with these simulators. So again, we'd love to have you to our factory to do some ILC training hands-on in our hot lab with the units, as well as the programming of that simulator. We like to keep it easy. The other thing over time is, as we progress through this, as a fairly recent launch, let's say, I love talking about applications for domestic water production, for space heating. As we get application drawings, we're going to add them into the mix to give you a more of a flavor for what can we do. If I have 2 heat pumps and 2 tanks, 2 heat pumps and 3 tanks, 1 heat pump and 3 tanks, what would that look like? How would I pipe those on multiple housekeeping pads? So I love applications, and of course we do have an application to design team that can help with these as well. In terms of the final startup and commissioning, we also completely understand and frankly fully appreciate that the refrigerant side of this process is a sealed chamber. We don't have to interact with it. That refrigerant is captured within the compressor, the piping, and this side of that brazed plate heat exchanger. But there is, on a startup and commissioning, an ability to go in and check those refrigerant temperatures and refrigerant pressures just as a visual and do that as a checkoff. So again, we're converting this over into pressure, PSI, as opposed to kilopascals. We're also converting it over into Fahrenheit as opposed to Celsius. So again, we can reference slide 8 that we talked about earlier, but we're also going to talk about a consequence. If you're doing a startup and commissioning, we can go on and look at that display screen and look and register what our Fahrenheit pressures or Fahrenheit temperatures are, as well as what our pressures are. And we can note a consequence. If we have an undercharge or correct refrigerant pressure or overpressure, it's going to manifest itself in a couple of ways. So we do have a guide here that we can reference what that cause and effect will be. If we have an overcharge, too much refrigerant in the system, here's how it's going to manifest itself. Here's those numbers that we're going to look for on this screen. So I think this is also very helpful on a startup and commissioning to demystify the process, remove the intimidation factor, and say, we have a refrigerant, we don't have to interact with it physically, but we can go in and note what those refrigerant pressures and temperatures are in terms of that startup and commissioning process. I think this is very helpful in terms of also understanding what it is we're doing and what that normal operation will look like. So also, what is if I have an undercharge system, if I've lost refrigerant somehow, how's that going to manifest itself? And we can again look for those temperatures and pressures in that system, note it up on our startup and commissioning, and make this process very simple and straightforward. Well, that was a whirlwind tour for startup and commissioning of heat pumps. Again, this will be a recorded webinar. I do have this available as a PDF if you want to email me. This will go on our Raypak training website. Again, in the future, I believe we're going to add more real-world test site jobs, get some pictures, get some other applications for you to look at, so you have a frame of reference. My only ask from today's training, if you would be so kind, take out your smart device and your phone, just hold that camera up there, scan this QR code, take part in our survey, give us your feedback. What would you like to see more of? What would you like to see less of? Those types of things. So it's a way for you to also interact with us by conducting this survey. It will ask you for an event ID. This particular event ID is 1409. And again, just a very good way for you to interact with us, give us your feedback. I'll leave this up for just another minute here. Said that too soon. There we go. And then finally, there's my email. If you'd like to email me, I'd be glad to give you a PDF copy of this presentation. With that, I'll go ahead and pause, see if there's any questions, comments. Unmute yourself if you'd like to ask any questions. Okay. Well, if there aren't any questions, again, on behalf of Raypak and Raypak training team, I want to thank you for joining us today, and look forward to talking to you again soon. Take care.